Hey there, sixth graders. Ms.Waage here, and I've got my special friend Bob here to help us with today's math lesson because he's really good at looking at graphs and creating tables and equations, which is exactly what you're about to do. So let's get to it. All right, we're looking at example 1 here, which is about Tracy's lawn mowing business. So it shows that for one lawn, she makes $6. 2 lawns, she makes $12. 3 lawns, she makes $18. And 4 lawns, she makes $24. So this was made into a table, which is going to help you create the equation because this is what we've been working on, so it's easy to see that pattern. We can tell that, oh, it's going up by 6s. So that means that's my coefficient that I'm multiplying with my x, or with m in this case. So the equation that we come up with is D equals 6m. So D is our y-axis, or our money earned here. Or you could write it as y equals 6x. They're the same thing. Okay? If we look at number 2, it's working with plant growth. So the last problem was working with multiplication. This one's going to be a little bit different. So at 0 weeks, the height of the plant was 10. We're going to say it's 10 inches. At 1 week, it was 11. 2 weeks, it's 12. 3 weeks, it's 13. 4 weeks, it's 14. So as you can see, it's going up by 1 inch each week, which is shown here on the table. So at 0 weeks, that's its starting height, and from then it just grows 1 inch each week. So the equation, it's not multiplication this time, but rather addition. So height equals 10, which is where it started at, and then plus W, because it's 1 inch for each week. So you could have a 1 here in front of the W, but you don't necessarily need it. So it's just plus the W there, because 10 plus 1 equals 11, 10 plus 2 equals 12, 10 plus 3 equals 13, and so on. All right, we're going to look at our first problem here that we're doing together. So we've got Itzel's ice cream bars. So the ice cream bars are the x-axis, and that represents how many she's sold. And then the money earned is how much money she's made off of each ice cream bar, and they're all the same price. So at 0 ice cream bars, she makes $0. That makes sense. At 1 ice cream bar, she makes $1.50, which I've started the table here. So I just wrote it as 1.5, just to save a little room there. For 2 ice cream bars, she makes $3. For 3 ice cream bars, she makes $4.50. And for 4 ice cream bars, she makes $6. So we just need the unit rate. So when x equals 1, so remember this is x and this is y, x and y. So we already have that value here. So we have our coefficient. We can tell that this is a multiplication sentence or equation because it's going up by the same rate every time. So we now have the unit rate, the rate per 1 that is needed to create the equation. So we can say M for money equals 1.5 times B. So money equals 1.5 times the number of bars sold. You could also write that like this, times B. We don't really want to use the normal sign of multiplication like this because it can easily be confused with x. We could also write as y equals 1.5x. Okay? Number 2, Martin is working on math homework. He completes the same number of problems each minute. Let H represent the number of hours he works, and let P represent the number of problems completed. So it's going up by a half hour each time, and then it shows how many problems he's completed. So we're going to go ahead and make the table, and then from there create the equation. So, I'll write that as X or H. That's the hours. And then the problems completed is P, which is also thought of as Y. So our x-axis and our y-axis. So when H equals 0, so hours is 0, he completes 0 problems. That makes sense? At 1/2 an hour, so 0.5, he completes 8 problems. In 1 hour, he completes 16 problems. In 1.5 hours, he completes 24. And in 2 hours, he completes 32. So just like the last problem, this is multiplication. It's going up at an even rate. So we just need to find the unit rate. which in this case is right here when x equals 1. So we can take that unit rate and make our equation because we have our coefficient, our number that we multiply times our variable. So our equation just becomes P equals 16 times H. So that means he completes 16 problems in 1 hour. We can see that here. In 2 hours, he completed 32. So that makes sense for our equation because 16 times 2 is 32. So as you're doing this in your notebook, you don't necessarily need to draw the graph. You can if you want, just a rough sketch of it. And then you'll want to create the table and the equation just to help you out. Okay? Go ahead and do number 3. So each shirt mighty T is the same price. Let S represent the number of shirts sold, and let D represent the total money made. So we've got our shirts sold on the x-axis and our money on the y. So for 0, I'm going to go ahead and draw the table, although let's squeeze it over here. So shirts sold is S, and money made is y. So 0 and 0. And then we've got 2 for 2 shirts, they make $16. For 4 shirts, they make $32. For 6 shirts, they make $48. And for 8, they make $64. So with this one, we don't have the unit rate easily right out in front of us. But we can notice the pattern. We can see the relationship between x and y. So 2 times what is going to give me that 16? Well, I know 2 times 8 equals 16. Let's check and see if that's the same for the next one. 4 times 8 equals 32. Yep. 6 times 8 equals 48. Yes, so we know that each shirt is going to cost $8 because that would be representing the relationship there. And if we were to look at where 1 would be on the graph right here, and we went straight up, it would follow right in that line with the other dots. So our equation would be M equals 8 times S. So money equals $8 times the number of shirts, or Y equals 8X. All right, number 4. The dunk tank charges $1 for each ticket. When the fair started, they had $20 in their cash box. Let T represent the number of tickets sold, and let M represent the total number of money in their cash box. So this is going to be an addition problem rather than a multiplication like the last couple. So we see that at 0, they started out with $20. That's because that's what they had in their cash box to start. So tickets sold and money. So at 0 tickets, they already had $20 because that's what they start out with in their cash box. From then on, we can see at 5 tickets sold, they then had $25. So 5, 25. At $10 or 10 tickets, they had $30. At 15, they had 35. I don't have room for the next one, but we can see that they started off at 20, and then they added, it looks like from 20 to 25, I added $5 for each ticket. So I added, it's basically showing that each ticket is $1. So our equation would be M equals 20 plus T, the number of tickets. We can check and see if that works for each problem. So T plus 0, or T equals 0, 20 plus 0 equals 20. Yes. For the next one, T is 5, 20 plus 5 equals 25. Yep. T is 10, 10 plus 20 equals 30. So this one is an addition problem. You just have to check and make sure that it works for each part of your table. All right. I think that's where we're going to stop for today because I'm going to run out of time here. But good luck with the rest of the lesson. You guys got it. If you need help, office hours, you know when they are.